Ladies and gentlemen, Dr. Peyam.
Alright, thanks for watching, and sort of inspired by my work on the integral of e of minus x squared, I will calculate another integral whose function does not have a simple antiderivative. Namely, today we'll calculate the integral of ln of sine of x from 0 to pi over 2. But I would just like to say, this was not my original idea. The credit goes to Zach Lee, and you're very welcome and in fact encouraged to check out his channel, which is in the description box. Alright, so let's get started. So goal, and if you all know sine of x, you know it looks like this, goes from 0 to 1 at pi over 2. So from 0 plus to 1, and therefore ln of this should look like, so this is sine of x, ln of sine of x should go from negative infinity to 0. ln of sine of x. So it is a very interesting function because even though the function is infinite at 0 plus, the area under it will still be finite. Whoa. Okay. Alright, and so how do we do this? It's actually very, very cute, although Oreo is cuter. Okay, because it's a very similar trick to the e of minus x squared. So let I be our desired integral prior to ln of sine of x. It turns out, magically, that we can not substitute, we can change this integral into a similar integral, because whoever says sine says cosine. So, let's do that. Okay. Namely, I don't know if you know this formula, but we know that sine of pi over 2 minus x, so sine of 90 degrees minus x, equals to cosine of x. So based on this really clever observation, it might be useful to use a kind of substitution like this. So in fact, let u be pi over 2 minus x. Then we know that du equals to minus dx, and x becomes, if you put x here and u here, you get x equals to pi over 2 minus u. So in other words, this integral becomes, so if x is 0, u is pi over 2. If x is pi over 2, u is 0. So in fact you get ln of sine of pi over 2 minus u, okay, minus du. Pikachu, I choose pi over 2 minus u. Alright, so, and therefore, because of this minus and this weird thing that has completely the wrong orientation, this integral, in fact, becomes integral from 0 to pi over 2 ln of sine of u, sine of pi over 2 minus u du. But as I said, we have this nice formula that sine of pi over 2 minus x is cosine of x. So this becomes integral from 0 to pi over 2 ln of cosine of u. So that is really, really cool, because it turns out the integral of ln of sine of x from 0 to pi over 2 is exactly the same as the integral from 0 to pi over 2 of ln cosine of x dx. So this is beautiful symmetry involved in some sense. And let's see how we can put this to our advantage. Because what do we have? On the one hand, we have that I equals to the integral from 0 to pi over 2 of ln sine of x dx. On the other hand, I is integral from 0 to pi over 2 ln of cosine of x dx. Well, before with e of minus x squared we multiplied them, now we will add them. Because the sum of ln's, they literally multiply like bunnies do, because ln of a plus ln of a plus ln of b is ln of a times b. And you might say, what the hell, Peyam? Why did you take this nice integral and turn this into this messy integral? It turns out, and here's the roadmap for the rest, we can turn this into an integral of ln of sine of something that's a little bit more complicated, but we will turn this into an easier integral using another substitution. So that was step 1. Now let's do step 2. So this still 2i equals to, as I said, we want to turn this into a sine, but if you remember, sine of 2x is in fact 2 times sine of x cosine of x. So in particular, sine of x cosine of x, what we have here, is 1/2 sine of 2x. So this whole thing becomes, in fact, ln of 1/2 sine of 2x dx. As I said, we have ln of a product, ln degeneres, right? So it's ln of 1/2 plus ln of sine of 2x dx. But again, ln of 1/2 is minus ln of 2, and if you integrate that constant from 0 to pi over 2, you in fact get minus pi over 2 ln of 2 plus this junk. I did turn this into a very complicated integral, but again, just be patient, as Barney says, wait for it. So now, for the rest of this talk, let's deal with this sucker, okay? And alright, so how do we, how do we destroy this?
Dear audience.
It would be nice if we can turn this 2x into x, because then we would have 2i equals to junk plus I. But wait, we can. It's called substitution rule. So again, let u be 2x. So I guess step 3. Let u be 2x. du is 2dx, right? And everything. So then this integral from 0 to pi over 2, ln of sine of 2x dx becomes integral, so from 0 to pi, ln of sine of u, so dx is 1/2 du. Okay, not bad. This looks almost like what we want, except we have an integral from 0 to pi. No problem, let's just split it out. Let's do some mathematical surgery, because the integral from 0 to pi, we can write this as the integral from 0 to pi over 2, and the integral from pi over 2 to pi. So today is a very delicious integral, because we have lots of pi. So ln sine of u du plus 1/2 integral from pi over 2 to pi ln of sine of u du. But wait a moment, this is exactly what we want, because this is I. Who is that? 1/2 I plus this junk. So what you'll see, there's a little bit of magic happening here. ln of sine of u du. Because, well, we really liked, this change of variable, pi over 2 minus u, so let's just do it again. So now let's do another change of variable. So let v be pi over 2 minus u. And the reason this is so nice is because this allows us to change this pi over 2 to 0, which we want. And, well, pi becomes minus pi over 2, but no problem, So dv equals to minus du. So this thing, okay, becomes 1/2 integral from 0 to minus pi over 2 ln of sine of pi over 2 minus v minus dv. It's almost like DVD, but not quite. Okay. Again, what the hell am I doing? I have this hard integral. I turned this into this worse integral. Okay. No! Anyway. Alright, so it turns out though that this is very nice because we still have this minus, so minus 1/2 integral from 0 to minus pi over 2 ln sine of pi over 2 minus junk is cosine of that junk, okay, cosine of v dv. Okay. Now, weird orientation, no problem, cancels out with this minus. So we get integral from 0 to minus pi over 2 ln, integral from minus pi over 2 to 0 ln of cosine of v dv. But look, ln of cosine of v is an even function. So whatever this looks like, I don't know, doesn't look like this, but doesn't matter. Suppose it looks like this. Well, because we have an even function, the integral, the area from pi over 2 to minus pi over 2 to 0 is the same as the area from 0 to pi over 2. So in fact, this integral becomes 1/2 integral from 0 to pi over 2 ln of cosine of v dv. If you're not convinced, you can do yet another change of variable. W is minus v, and you get the same thing. But look, we get 1/2 integral from 0 to pi over 2 ln of cosine of v dv, but we said this is actually equal to I, this thing. You know, it doesn't matter if you put cosine of sine. So we get 1/2 I. And so what did we do? Okay, we had that 2I equals to minus pi over 2 ln of 2 plus this thing. So I feel like this is the grand finale. 2I equals to minus pi over 2 ln of 2 plus this integral. So integral from 0 to pi over 2 ln of sine of 2x dx. Is that it? And then we did the change of variables. We found that this integral becomes 1/2 I. Alright? And then we found out that this integral becomes 1/2 I. Which we get, you know, minus pi over 2 ln of 2 plus I. So 2I is minus pi over 2 ln of 2 plus I. Well, put this I here, so an I for an I, and I minus I is minus pi over 2 ln of 2. I is minus pi over 2 ln 2. And I am done.
Wow.
Thank you, Zach Lee, again, for this fantastic idea and suggestion.
Wow. Woo.